Hey everyone, so we are going to go into the next video in the series of working with exceptions, and the topics we're going to cover today are matching exception types. We're going to cover the get message method. We're going to cover polymorphic references to exceptions and how to handle multiple exceptions with multiple catch blocks. So starting off with matching exception types, so the idea here is whatever code you have in the try block that can throw some potential exceptions, you have to match the exception type in the catch block. I'll give you an example. If I do a system out print line, wait for my computer to catch up here. There we go. System out print line, and we just divide something by 0. If I demonstrate this, just so you can see the exception, it's an arithmetic exception. So if we put that in a try and catch, the correct type of exception to catch is an arithmetic exception EX. And you can see that that works. Well, if I tried to catch maybe a file not found exception, you could read the error message here: unreachable catch block for file not found exception. This exception is never thrown from the try body. So that demonstrates that you have to have matching exception types. Now, you can catch the exception itself, or later on you'll learn that you can any of the parents can catch with that exception type. And so we'll talk about that a little bit more with polymorphic references to exceptions. The next topic then is the get message method. And so let's go ahead and catch an arithmetic exception, so we get rid of that error. And this is just the name of our reference variable. I'll call it EX. You could call it whatever you wish. I'm just going to keep it EX, but again, if you want to orange, it doesn't even matter. But just EX to me says, okay, this is an exception reference variable. And what EX has available to it, if I do EX dot, there's a toString and a get message, and the get message is the method that we're referencing here. And so again, the whole purpose of this is to gracefully handle the errors. Now this is not graceful, right? We already discussed that this crashes your program, and if this were to occur in a real program, you might see your application is not responding, or just freezes, or you see a nasty red error message and it crashes. Whereas this is a more gracefully handling runtime errors, aka exceptions. And so now we run this, and you can see that there is a divide by 0, and so that is the problem that's occurring. This get message is going to be a method that reports, in a more graceful manner what's happening. Again, much more graceful than the red text that a typical end user, reading this, they're going to have no idea what the problem is. I mean, I guess they could read into it a little bit, and they could, apply some logic and figure it out, but they're just going to see this. They're not going to know what main is, demo.main, demo.9, arithmetic exception, they really don't know. Whereas if you provide a more graceful solution in this try catch block, you can say, hey, here, you might say a problem has occurred. A problem has occurred. You can say the description is something along these lines, where you're providing a generic error message. A problem has occurred. The description is divide by 0. Sometimes in a lot of programs you'll just see a problem has occurred. Please contact your administrator for more help. But that's the get message, and this method is inherited by all of the classes that inherit from exception. So it's an inherited method, therefore all of these classes that we're learning about, they should all have it, and you could use it in all of these classes and all of the catch blocks. The next concept is a polymorphic reference to exceptions, and the theory there is that any parent or grandparent or great grandparent can catch an exception from any of the children or great grandchildren, etc. Okay, so really what it means is if you're in the same, if your parent or your grandparent or your great grandparent, of a class, it can catch any of its children. So here, arithmetic exception, the one class exception is the great grandparent of what are called checked exceptions, and checked exceptions are the ones that we try and handle. We try and catch blocks. We talk about unchecked exceptions, like, hey, the computer runs out of RAM. Can't really do much about that. So I'm just going to take my example from up above and show you that, well, since we know arithmetic exception, we know it is and we know its great grandparent is exception. Well, we can use exception to catch this arithmetic exception, and this will work. Earlier we said file not found exception. Well, they're in a different hierarchy. They're not in the same lineage. So this will still work, and you can see, because of dynamic method binding, we still get the same error message, which is really nice. So here we have exception EX, and it will catch an arithmetic exception. And just to prove my point, I realize you realize this works, and so maybe you're just taking me at my word that arithmetic exception inherits from exception. But if I just go to the Java API really quick, and I do a Control F for arithmetic there we go, arithmetic exception. Over on the left, I'm going to click arithmetic exception, and you can see that arithmetic exception inherits from runtime exception, which inherits from java.lang.exception. So you can see that the grandparent of arithmetic exception is indeed exception class. And so if you're ever curious about the hierarchy of what are the parents or great grandparents, you can always go to the Java API and look up the class over here on this sidebar. You can see all the classes listed, which is a pretty nice feature. Okay, now moving on to the last topic is handling multiple exceptions. The important thing to realize here that now this is done with multiple catch blocks. So you can have one try block with multiple catch blocks, and the rule of thumb is that the catch clauses must be from most specific, which is lower in the class hierarchy, from most specific to most general, which is higher in class hierarchy. So let's give a demonstration here. And to do that, I'm going to open up my Java API again. And I'm going to look up a class called illegal argument exception. Okay, so we could see that it's a similar hierarchy to the last exception that we looked up. Let me go back and I'm going to look up number format exception. And you can see here the number format exception is a child to illegal argument exception, right? So going back to our demonstration, your catch clauses must be from specific, lower in the hierarchy, to most general. So in this scenario, our first catch block needs to be number format exception, then an illegal argument exception, right? From specific to general. So let's go ahead and code that. We're going to go ahead and put a try block, and let's go ahead and declare int number, and number equals integer dot parse int, and let's go ahead and pass it a string of someone's name. Hano. Right, so this is going to cause an exception to occur because we're trying to parse someone's name into an int, and it's going to cause a problem. So let's code this correctly first. We have two catch blocks. And going back here, we want to code the number format exception first. And let's just use the method from the for ex get message, followed by illegal argument exception. Copy this, paste this. So again, we're going from more specific or lower in the hierarchy to more general or higher, and this is the correct order to code your catch blocks. And so if I run this here, we get just, hey, for input string Hano, which is actually coming from the format, right? The format is incorrect. So this error message that we were seeing here for input string Hano comes from number format exception. And if I were to code this the other way around, put this catch block, let me cut that just to show you the error message. This would have what's called an unreachable block of code. Unreachable catch block, it is already handled by this catch block, right? Because any child can be caught by a parent. So since this is a parent of number format exception, it's going to catch a number format exception if it's thrown in this scenario. So that's how we handle multiple exception with multiple catch blocks, and that's the rule, right? You have to handle them from lower in the hierarchy to general higher in the hierarchy. So that wraps up this video.